Welcome to my class. Today we look at permutations and combinations. Now, so we begin by first of all getting to know what a permutation is and what combinations is. And I've given the definition here. I've said that a permutation is just an arrangement of objects in a particular order. So if you're given some objects and then you are told to arrange them in following a certain order, and then that is a permutation. But in combination, we'll be looking at how to arrange those objects or select the objects without necessarily following any order. Just before we go to the formulas of how to do permutations and combinations, let me just try to explain the definition. Now, just to make the definition clear, what I'm saying is, supposing we are given a set containing the elements ABC, and then we are told to arrange these elements. We can have the first arrangement as ABC, then we can have the second one as A, then followed by C, then B. That is, this order is different from this. We can also begin with B, then AC, or B, then CA, or we can also have C starting and followed by AB, or C starts, then we have BC. So how many arrangements are this? 1, 2, 3, 4, 5, 6, and then we say that these are 6 permutations. 6 permutations. You can see we have followed some order. There is this order here, A followed by B, and then C, and then we have this other order. So in permutations, order is very important. The order in which the elements are arranged is very important in permutation. But in combination, the order is not important. So for these elements, though these are 6 permutations, but this is just one combination. In terms of combination, it's regarded as one. It's just one, because this just the same as this, just the same as this, just the same as that. So they are all the same in terms of combinations. But in terms of permutations, we have 6 permutations. So let's look at how do we find permutations. For instance, how do I tell that this set has 6 permutations without necessarily having to write down the arrangements? Now, so I have in my definition 2, I've given the formula. I've said that the number of permutations for n objects, if I'm taking R at a time, I'm given n objects and then I'm asked to arrange R at a time, then the number of permutations will be given by n factorial divided by n minus R factorial. Now, the example that we've just done, I had 3 objects. So the question is, and I was arranging 3 at a time. So the question is, how many permutations? So I will say 3 factorial divided by 3 divided by minus 3 factorial. But this is just the same as 3 factorial, and 0 factorial is 1. So this is just 3 factorial, which is 3 times 2 times 1, which is 6. So this is how I'm able to tell the number of permutations. Now, so this is what I've written here. I've written on the formula. I've given that formula, and just below A, I have B, and the B says that the number of permutations of n objects taken all at a time will be given by n factorial. And we've seen this. I've said that if I have 3 objects, it will be 3 minus 3 factorial here and factorial there, and the denominator there is 0. 0 factorial is 1. So these are just the same as 3 factorial. So if I'm given n objects and I'm arranging n, all of them at a time, it will be out of n minus n factorial. So the denominator will give you 1, and so you just left with the n factorial. And that is why we say that the number of permutations of n objects taken all at a time is given by this. Now, so we have various textbooks that are giving us different ways to denote permutation. In this formula, I've denoted permutation by this, but I've said that some texts will denote permutations as this. We'll either denote it this way or this way or this way. In this video, I'll be denoting it using this, and in some places I'll also denote it using this last symbol here. Now, what about combination? The formula for the number of combinations is here. So if you are given n objects and you are told to select r at a time, then the number of combinations will be given by this. It will be given by n factorial divided by r factorial into n minus r factorial. In our previous example, we had 3 objects and we were selecting 3 at a time. So this would be out of 3 factorial. So our r is 3 and our n is also 3 in our previous example. So this would be 3 minus 3 factorial. And inside this denominator, what we have is 0. So 0 factorial is 1. So you are left with 3 factorial out of 3 factorial, which is just 1. That's why I say that in that example, that's why I said that though we had 6 permutations, the number of combinations were just 1. Now, so some books will denote combination this way. Denote it this way. Either this. In this video, I've denoted using this symbol, and then I've also denoted using this last symbol. In fact, some books will also denote it this way. Some books will also denote it that way. So it depends. Once you are reading a book, get to know what symbols they're using, and then you begin understanding, because you already have the definitions and the formulas from here. Now let's just look at examples straight away. Now let's look at this example. The example says that a code has 3 digits in a specific order, and the digits are between 0 and 9. How many different permutations are there if one digit may only be used once? So what we have here, these are the numbers we have. We have 0 up to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many digits are these? 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 10 digits. These are 10 digits. So the question is saying that if you're given these 10 digits and you're asked to arrange 3 at a time, how many arrangements can you make? How many permutations would there be? So that is the question. So since the order matters here, we use permutation, and we say that permutation, the number of permutations, if you're given 10, so our n here is 10. So the number of permutations of 10 objects taken 3 at a time will be given by 10 factorial divided by 10 minus 3 factorial. And this you can use your calculator. Your calculator has 10 factorial, and the denominator there is 7 factorial. So you can just use your calculator and find what 10 factorial is, and then what 7 factorial is, and then divide, and you have the answer. In fact, your calculator also has this permutation symbol there. You can still press permutation and then 10-3, yes, permutation 10-3, and get the answer 720. On your calculator, you can still do that. The only thing you need to understand is what question are we using the permutation formula, and which one are we using the combination formula. And you could still use your calculator straight away, because your calculator has the symbol for permutation and it also has the symbol for combination. Your calculator has these symbols. But for those that have calculators without these symbols, then you understand that you have 10 factorial divided by 7 factorial, and of course your calculator should be having 10 factorial notation. Your calculator should be having factorial notation. So just press 10 factorial, then divided by 7 factorial, and find the answer 720. Now, but of course you understand what we mean by 10 factorial. What we mean by 10 factorial is just 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And what we also mean by 7 factorial, because this will be 10 minus 3 is 7. It will be 7 times 6 times 5 times 4 times 3 times 2 times 1. So this is what we mean by 7 factorial. And you can see that this denominator would of course cancel with this part of the numerator. And what we are left with is 10 times 9 times 8, which is 720. So this is how we do it. Now, but of course I've shown you that there are several ways you could do it. You could do this question using a calculator. And if you do not want to do that, then you could still do using this formula here. And let's look at another example. Now, the question here is that find the number of 4-letter words that can be formed using the letters A, B, C, D, E, F, and G, if one letter may only be used once. So we do not want repeating some letters here. Now, so this question wants us to, we have this number of letters. These are 1, 2, 3, 4, 5, 6, 7. These are 7 letters, and we are told to form words of 4 letters. 4-letter words. Whether they make meaning or not, we just want to make 4-letter words out of 7 letters. So the order here will be very important, because one may want to have A, B, C, D, another one may want to have B, C, D, A. So the order is very important here, and therefore we use permutation for this kind of person. And so it's permutation of 7 letters taken 4 at a time. So we are arranging 4 at a time. So this would be same as 7 factorial divided by 3 factorial, because 7 minus 4 is 3. And so using a calculator, you would find this to be 840. And of course, I showed you how to use a calculator in so many ways. But if you want to use a calculator, then this is just 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. And this gives you 7 times 6 times 5 times 4, and this part is 42 times 20, which is 840. Let's look at the next example. And the question is, how many different 4-digit numbers can you form using the digits, these digits? These are 4 digits. And we want to form 4-digit numbers. And we do not want to have any of the numbers used more than once. And if you go to our formula, we say that if we have n objects and we are arranging n at a time, we have n objects and we are arranging all of them at a time, then the number of permutations will be n factorial. So in this question, we have 4 letters, 4 numbers, and we are arranging them 4 at a time. So the answer will be 4 factorial, which is 24 when you use your calculator. But if you do not remember this, then just do it. Permutation of 4 taken 4 at a time, which will be 4 factorial divided by 4 minus 4 factorial. And this will be 4 factorial divided by 0 factorial. But 0 factorial is 1, and this is 4 factorial, which is 24. So you will still do it that way, and that's how we do this question. So as I said, I will go through as many examples as possible so that you understand the notion of permutations and combinations. If you have any question, you can still ask on the link, and I'll respond to it. Now, so we have this other question: in how many different ways can the letters of the word question be arranged so that the vowels always come together? So we have these letters here, the letters of the word question, that is Q, U, E, S, T, I, O, N. We want to arrange these letters so that the vowels will always be together. So the question is, in how many ways can this be done? Now, what are the vowels here? We have E, we have U, we have E, and then I and O. So those are the vowels. So the vowels are U, E, I, and O. So we want them to be always be coming together the way they are. Okay, we can arrange, we can even begin with the E, U, I, O, but they must be together. And so the consonants here are Q, we have Q, we have S and T, and then N. So we want these vowels, therefore, to be considered as one letter, so that we have 1, 2, 3, 4, 5 letters. Although we had 8, but the vowels are considered as one letter now. And that's why I've written here that we therefore assume that we have 5 different letters when we are regarding the vowels as one letter. So this will be 1, 2, 3, 4, 5, 6, 7, 8. And so that there were 8, but now since the vowels are one letter, we now have 1, 2, 3, 4, 5 letters. And we want to arrange, so the question is, in how many different ways can the letters of this word be arranged so that the vowels always come together? Now we have 5 letters, and we want to arrange all the 5 letters at a time. So we want to arrange all the 5 letters at a time. That would be 5 factorial. We shall have 120 permutations, or different ways. 120 different ways of arranging these 5 letters. But then we ask ourselves, what about among the vowels? How many ways can we arrange these vowels? Because these vowels, we can begin with the E, then U, then E, the way it is here. Or somebody may want to begin with the U, then I, then O, then E. That is another way. You can also have E or IU, that's another way. So we're asking ourselves that, therefore, among the vowels, in how many ways can you arrange these vowels? How many ways can you arrange these vowels? And we can see that there are 4 vowels. And they're different. Of course, they're different. None of them is repeated here. So the number of ways you can arrange 4 different vowels is 4 factorial, which is 24. So we discovered that the 5 letters, different letters, were to be arranged in 120 ways. And the 4 different vowels are to be arranged in 24 different ways. And therefore, what does the question want? The question wants us, in how many ways can you arrange the letters of this word? So the number of ways you can arrange the letters of this word is this 120 times this 24. And that gives you 2880 ways. And I've just explained that here. So for those who are writing notes, this is my working and explanation. So I've said that since we want the vowels to always be together, we will consider them as one letter, and so that we then have 5 letters. And to arrange the 5 letters, which are different, these are different 5 letters. None of them is similar. And so it will be 5 factorial. That will give us 120 ways. And then among the vowels, there are 4 vowels which are also different. And so we can arrange them in 4 factorial ways, which is 24 ways. And therefore, the required number of ways will be 120 times 24. Now we'll be looking at questions similar to this, but slightly different, and see how to work out those ones. Now, I've been talking of when we looked at that question, I was using the word different letters. So in this section, we want to look at, we are given letters, some of which are similar, and we are asked to arrange. So that's what I've written here. I've said that we now want to find number of permutations of n objects, some of which are similar. So let's assume that we are given n objects, and that n1 objects are similar, n2 objects are similar, all the way up to nr objects are similar. Then how do we find the number of permutations? The number of permutations will be n factorial divided by the first number of objects which are similar, factorial of that, times the second number, times the third number, and so on. Let me just take you to an example so that you understand what I mean. Now, the question is, find the number of 11-letter words that can be formed using the letters of the word corporation. So we want to use the letters of this word to form 11-letter words. First of all, how many letters are these? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 letters, and we want to arrange all of them at a time. So the question is, how many arrangements would we come up with? Now, when you look at these letters, you discover that some of them are similar. For instance, you have an O, and O. O appears 3 times. O's are 3. And then we can also see that we have R, which is similar to the other R. We have R's are 2. So we also want to see whether we have other letters that are similar. C is not similar to another one, P is not, T is not, N is not. So these are the only similar letters. So the question is, how many arrangements can we have? because we have this O is similar to that, so you cannot know which O you are using at what time, because they are similar. So the number of permutations, therefore, of 11 objects where 3 are similar and 2 are also similar, is given by 11 factorial divided by 3 factorial times 2 factorial. And when you do this using a calculator, you would find that this will be the number of permutations. This will be the number of permutations, 3,326,400 permutations. And what is important here is that some of the objects were similar, and you then discover that the formula is slightly different from the other formula we've been using before, where the objects were not similar. So when the objects are similar, the formula becomes slightly different. And I hope you've noticed that difference. Let's look at another question just to make it easier. The question is, find the number of 5-letter words that can be formed using the letters of the word daddy. So you can see that these are 5 letters, and we want to form a 5-letter word, 5-letter words. In other words, arrange all these letters. How many arrangements will you come up with? Now this is very easy. I just need to notice that we have some letters which are similar. D, we have these are 3, and those are the only letters which are similar. So straight away we go to the formula. The number of permutations of 5 letters where 3 are similar is given by 5 factorial divided by 3 factorial. So that is only similar. Those are the only similar ones. There are 3. So this gives you 20. Just use your calculator. Calculator has 5 factorial and it has 3 factorial notations. Now, so I hope that makes it very much clear that when you have objects which are similar, then our formula becomes slightly different from the one we started with. Now, I want to look at slightly different question. And the question is, in how many different ways can the letters of the word corporations be arranged so that the vowels always come together? Now, this question is slightly different from the earlier one. The earlier one, we did not have letters which were similar. But for these ones, for this question, we have letters which are similar. So let's see how to do this. What are the vowels? The vowels here are O, R. So you have O, this is A, then I-O. So these vowels must always come together. So they be considered as one letter. What about the consonants? The consonants, we have C, we have R, P, R, then T, N, S. C, R, P, R, T, N, S. And these are O, A, I. Now, so the question is, how many permutations can we have? So how many letters do you have, first of all? We have 1, 2, 3, 4, 5, 6, 7, 8 letters. We have 8 letters because we've been told that the vowels must always come together. So we consider the vowels as one letter first. Now, of these 8 letters, we notice that R appears twice. So R's are 2. The R's are 2. Which other ones are similar? R are similar. The other ones are not similar. So we are given 8 letters. Permutation of 8 letters where 2 are similar will be given by 8 factorial divided by 2 factorial. Use your calculator and see what you get. Let me just see what I was getting. Let me scroll down. Yeah, so 8 factorial over 2 factorial is giving me 20,160 words. Now, so just as we did earlier, we now consider what about among the vowels? How many permutations will there be? So we have been given these vowels. How many arrangements can you make? How many vowels are these? These are 1, 2, 3, 4, 5. These are 5 vowels. But of these 5 vowels, O's are 3. They are similar. So that means, and that's what I've done here, I've said that therefore the permutation of among the vowels will be the permutation of 5 objects where 3 are similar, and that will be 5 factorial over 3 factorial, which is 20. So therefore, what does the question want? The question wants us to multiply this, or the required number of words would therefore be this times that, which is this. And that's how we do this type of question. So just similar, where the earlier one we did not have repetitions, we did not have objects which were similar. But for this, now let's look at this other question. And the question is, in how many ways can the letters of the word internet be arranged so that the vowels always come together? So this question is just to emphasize example 11, which we did. So we'll be doing it in the same way. The internet has which vowels? It has I, it has E, and then E. Those are the only vowels. So we'll consider these vowels as one letter. And then the consonants here, we have NT, NT, RN, RN, then TS. So how many letters do we have? We have 1, 2, 3, 4, 5, 6, 7 letters. We have 7 letters. Of these 7 letters, which ones are similar? We have N. N's are 2. N's are 2. We have this and that. And the T's are also 2. T's are also 2. So we have 2 and 2. So therefore, the permutation of 7 letters where 2 and 2 are similar will be 7 factorial divided by 2 factorial times 2 factorial. So this one you can use your calculator. And when you use your calculator, what was I getting using my calculator? Let me just scroll down. Yes, it's here. The number of ways to arrange those 7 objects should be this 7 factorial out of 2 factorial times 2 factorial. And that gives you 1,260 words. Now you have now to check what about among the vowels. How many permutations are there? How many vowels do we have? We had I, we had E, and then E. We had this I, E, then E. Those are the only vowels, and these are 3 letters. So permutation of 3 letters where 2 are similar. 2 are similar, E and E, and this would be 3. That would be 3. So therefore, the number of ways in which we can arrange the letter of the word internet is 1,160 times 3. Those are the number of ways. When you multiply those two, what you get is 3,780 words. You can come up with those words. I think that example is enough. Those 2 examples are enough to that type of question. So let's look at this other question. And the question is, how many 3-letter words with or without meaning can be formed out of the letter of the word question if repetition of letters is not allowed? So we've done a question like this, but I just want to repeat so that we understand it. So, and in fact, these letters, none of them are similar. None of them is similar. None of them is similar. And how many letters do we have? 1, 2, 3, 4, 5, 6, 7, 8. We have 8 letters, and we want to arrange 3 at a time. So this will just be 8 factorial divided by 8 minus 3 factorial, which is just 8 factorial out of 5 factorial. And this is 336. So I've just brought this question here because I want you to see how we've been doing the earlier two examples, and then this example where none of the letters repeat is similar. And although we had done it earlier, I've just brought it here so that you can remember what we did earlier. Now, of course, this is what we've just been doing, and I told you that permutations, we can either write it this way, 10-3, or we can write it as this, or we can write it as this. So many books have different ways of writing. But the question is this, then do it. For us to do it, we know that we have 10 objects and we are arranging 3 at a time. We have 10 objects arranging 3 at a time. So this will be given as 10 factorial divided by 10 minus 3 factorial, which is 7. And of course, I gave an alternative way of doing it. An alternative way of doing it is this. I know that 10 minus 3 will be 7. So 7 has cancelled out. 7 factorial. So I'm left with the 10 times 9 times 8. But this is what I did. I said that if I'm given n objects and I'm arranging r at a time, the form is n minus 2 all the way up to times n minus r plus 1. So using this formula, my n is 10 for this question. Is my n. And my r is 3. What about n minus r plus 1? I just want to determine the last term here. I just want to determine this last term. N minus r plus 1 would be 10 minus 3, which is 7, plus 1, which is 8. So by this formula, it means I'll begin multiplying by from here up to here. And what is n? N is 10. N minus 1 will be 9. N minus 2 all the way up to this point. But this point is 8. So in fact, that is where we are. So that means permutation of 10 objects taken 3 at a time will be given by this. The same thing here. You can do it either using this example or this other example. This other example, you only need to discover what is n minus r plus 1. So our n, of course, is 35. And r is 3, then plus 1. This will be 32 plus that, which is 33. So you're multiplying from 35 up to 33. It will be 35 times 34 times 33. And you get this answer. Or you can use this formula and get the same answer. But that formula will be very important. This formula will be very important in some questions, like the one I just want to look at. The one I want to look at is this one. The question is, find n if the permutation of n objects taken 2 at a time is 132. So my n is n, my r is 2, and what about n minus r plus 1? So n minus 1 r plus. So this is the same as n minus 2 plus 1, which is just n minus. So then I'll be multiplying from n all the way up to this. So it will be n times n minus 1. So just testing 1 as you go. And this is what I'm told that is 132. So this would be n squared minus n minus 132 is equals to 0. And when you factorize this, you'll find that n will be 12 or negative 11. But n is a positive number, and that is why I settled on 12 and not negative 11, because n is a positive number. N is positive. Because we are talking of permutation of n objects taken 2 at a time. So 12 objects taken 2 at a time. Now let's look at this other example. How many words of 4 consonants and 3 vowels can be formed out of 8 consonants and 3 vowels? Now, so what you notice is that this question here involves combinations, because we've been given 8 consonants, and then we are told that out of these consonants, select 4 at a time and group them. Group 4 at a time. And out of these 5 vowels, group 3 at a time. That's the same way I showed you when you were starting this video. I said that if we have this ABC and we have this BC, that these are 2 permutations, but of course 1 combination. That this group is the same as this group. This group is the same as this group. They have the same elements. They only become different if I were to have this. If I was to have this and then have A, C, D. So these are different. This will be different. But there will be different combinations, because this combination has these 3 and this combination has these 3. But in terms of if I were to consider the first 2, this is 1 combination. This group and this group is the same groups. So the order is not necessary. So this question is asking us, how many groups of 4 consonants can we form out of 8 consonants? And how many groups of 3 vowels can we form out of 5 vowels? So therefore, we just use the formula of combination. We have 8 consonants, and we want to pick 4 at a time. And so this will be 8 factorial divided by 4 factorial into 8 minus 4 factorial. And what about for the vowels? We have 5 vowels, and we want to group 3 at a time. And so this will be 5 factorial out of out of 3 factorial times 5 minus 3 factorial. So these are the number of groups you can have. If you multiply, if you are to multiply now, the answer you get here multiplied by the answer you have here, what you have are the groups. And you can come up with those groups. And those groups will be having 4 consonants and 3 vowels. So in fact, the group will be having 7 letters. So the question is, how many words can we form? So after you found the groups to be 700, let me just see what I got, because I have to multiply those 2 results. I had to multiply this 8 consonants, and we want to group 4 at a time, times 5 consonants, and we want to group 3 at a time. That was giving 700. And these 700 groups, I discovered that it had 4 consonants. So then I asked myself, these 7 different letters, in how many ways can we arrange them? In how many ways can we arrange 7 different letters? And you discover that since they're different, you have to be 7 factorial, which is 5040. So therefore, the question was, how many words can we form? Therefore, the number of words that we can form is the 700 that we obtained at this step. This 700 times this 5040. And these are the number of words that we can form out of 8 consonants and 5 vowels. If we were to pick 4 consonants at a time and 3 consonants at a time, no, 3 vowels at a time. So that is what we're supposed to do for this question. Remember that this question involves letters. So those letters, we will first of all find the groups, how many groups, and then we ask ourselves, since the letters, we need to arrange them. So in how many ways can we arrange those letters? And those number of ways that we found was 50, 40, and then multiply this to get the required results. Now we'll see this other one, question 18 here, example 18. Example 18 says that a businessman buys 5 laptops, 2 phones, and 3 tablets from a wholesaler, 6 tablets. How many choices does the businessman have? So again, this question here involves combinations and not permutation. Because we are just asking out of 7 laptops, you have 7 laptops, let me say ABC, and you want to buy 5. How many choices do you have? You want to buy 5, because if you have, let me say, A, B, C, D, E, F, G, 1, 2, 3, 4, 5, 6, 7. These are the laptops. You may want to, because you want to buy 5, you may want to buy 1, 2, 3, 4, 5. You want to buy the first ones. Or you may want to buy A, B, C, D, and then F. Or you may want to buy A, B, C, D, and then G. Or you may want to buy B, C, D, E, then F, and so on. So you're asking ourselves, how many such choices do you have? And to see that here the order will not matter. So it will just be the number of laptops you can buy. If you wanted to buy 5 out of 7, the number of choices that we have will be combination of 7, 5 at a time. And this will be 7 factorial out of 5 factorial, 2 factorial. You know how I got this 2? 7 minus 5. And then you also want to buy 2 phones out of 5. So it will be combination of 5, 2. And that will be 5 factorial out of 2 factorial times 3 factorial. We now got 3. You know the formula is supposed to be, what was the formula here? The formula was combination of n objects taken r at a time would be n factorial divided by r factorial and then n minus r factorial. combination 6, 3, which is 6 factorial out of 3 factorial, 3 factorial. Now, since this businessman wants to buy these tablets and go with all of them at home, the result that we need is therefore the product of this, product of this times this times this. That is the required answer. And so I've explained it here for the sake of those who are writing notes. I've explained here, and you can see that with this three, which is 4,200 ways. You have all these ways of buying those items. Now let's look at this. A mathematics club has 8 boys and 6 girls from the club. In how many different ways can they be selected, such that at least one girl is there? At least one girl. But we only want to choose 5 participants. So that means that the order here is not important. What we want is the groups. The groups. How many groups can we have, such that every group have at least one girl? So the first group that we see is that we might have a group of where all 5 are girls. Where all 5 are girls. That means you selecting 5 girls out of the 6. How many ways can that be done? Which is 6 factorial divided by 5 factorial. And this is just 6. That is the first way, because we just want that a group must have at least one girl. So a group can also have all the girls. So that is our first group. First group has all the girls. The second group, you may want it to have 4 girls and 1 boy. So 4 girls out of 6 is combination 6, 4. And 1 boy out of 8 is combination 8, 1. That's what I have here. And of course, the first, this one, is a 6 factorial out of 4 factorial times 2 factorial. And this one, that it's 8 factorial out of 1 factorial, 7 factorial. You can do it using a calculator. Now, so that is the first group. The second group, we may want to have 3 girls, 3 girls and 2 boys. Remember that the total number of participants must be 5. So 3 girls and 2 boys. But 3 girls from 6. So 3 girls from 6 and 2 boys from 8. 2 boys from 8. And you can do this, and get the answer. So that is the reasoning. That is the reasoning that I used to do this question, and the question has been done here. So this is why we briefly say that we can also have a group where you have 3 girls and 3 boys. 2 girls out of 6 and 3 boys out of 8. And then the other group is where you have 1 girl and 4 boys. And this is the last group, 4 boys out of 8. So the total number of ways is the first way. The first way, which was that, plus the second way. So this is our second way, plus the third way, plus the fourth, then plus the 5th way. And when you do that, this is what you get. You know how to perform these combinations. You have the formula. That is what you get. In fact, I've simplified it to give me 1946 as the required answer. What is important is just once you discover that the question involves combinations, then you can do it. You must be able to require permutations. Now let's look at this other one. A school has 9 male teachers and 8 female teachers. 6 teachers are to be selected to form a committee. So the order is not important. Just need 6. Just need 4 should be female. In how many ways can this be done? So again, we just reason the way we reasoned the previous question of 6. And this committee of 6 is coming out of 9 men. This committee of 6, 4 must be female. 4 must be female. Of course, the first, at least the question is at least 4. At least 4 must be female. That's the condition. So we can have a situation where all the 6 are female, and that is important. It's because we have at least 4. So we can have all the 6 being female, and it's 6 out of 8 females. So that is combination 8-6. The other situation is where you have 5 could be female and 2 could be male. Not 2, 1. 1, because the total must be 6. The total must be 6. So 5 female out of 8 is combination 8-5 times 1 male out of 9. 1 male out of 9. And then the other situation is where you have 4 female, and this will require 2 male. And of course, this is the last one, because you cannot go to where you have 3 female, because that will not meet this condition. So 4 female out of 8 is combination 8-4. And then 2 males out of 9, combination 9-2. Then you do this combination, do this, and just add the results. And you'll be having the answer that is needed for this question. That's what I did here. So you know how to do this. And of course, your calculator has this. Just press combination 8-6 and you get 28. But if you don't want, you just do it as 8 factorial out of 6 factorial 2 factorial, and you get 28. And this one 8 times this, and you get 6 times. And this one you do it, get 70. This one do it, get 36, multiply, and come up with this result. That one you can do it. In how many ways can a group of 4 girls and 3 boys be made out of a total of 80 girls and 5 boys? So this number should be girls, or at least this number should be boys. There's no condition. You just this like the previous one. You just want to select 4 girls out of 8 girls. So how many groups can we form? And then 3 boys out of 5 boys. And we did an example similar to this. So 4 out of 8 is this combination. And then 3 out of 5 is this combination. And then we want this group to have all the 4 girls and the 3 boys. And so the result means we multiply this. That means we multiply this. And when you do that, you get 700. Now let's come back to this type of questions. The question is, in how many ways can the letters of the word monies be arranged so that the vowels occupy only even positions? This question is slightly different from the earlier one. The earlier one, we said that the vowels should always come together. But this one, you want vowels to occupy even positions. So what vowels do you have? We have O, we have I, and then we have E. And then the rest are consonants, M, N, S. So how many even positions do you have? So, these how many letters? 1, 2, 3, 4, 5, 6. 6 letters. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So the even positions are this: 1 position, 2, and then 3 positions. So we have 3 even positions to be occupied by 3 vowels. The vowels are to occupy even positions. Now, the other positions will be occupied by the consonants. How many are they? 1, 2, and 3. So again, you have 3 positions to be occupied by vowels. How many vowels? 1, 2, no, consonants. 3 consonants to occupy this position, all the positions. And these even positions are occupied by the vowels. And that's what I wrote here, because I was just trying to understand what the question is. The question says, since we have those 3 vowels, and you want to arrange them, the order will be very important, because we have got these even positions. So this is odd, this is odd, this is odd, this is odd. So these even positions, I may begin with O, I, E. Or I may come and begin with O, then E, then I. Or I may begin with O, no, I may begin with I, then O, then E. So that means in arranging these vowels in even position, the order is very important. The order is very important, and therefore it means that this question involves permutations. This question involves permutation. That's why I said there are 3 even positions to be occupied by the vowels in this permutation. So it will be 3 positions, 3 vowels arranged 3 at a time. So it just be 3 factorial, which is 6 ways. There are 6 ways in which you can arrange those letters in the even positions. And of course, you have already seen that. You've already seen that if this is an even position, I can have this as E. I can also have this as O, E, I. And so on until I get 6 arrangements. What about the consonants occupying the remaining positions? They can also do that in 6 ways. That is 3 factorial, because there are 3. There are 3 consonants, and we are arranging all of them at a time. So therefore, what does the question say? That we have that 6 arranged, so that 6 ways. There will be that 6 ways, because you see, it depends on how you arrange the consonants and also the vowels. For instance, look at this. I can have M begin, followed by this. The way it is, no, these are vowels are following one another. Let me just put this. So the vowels, you can see the vowels 1, 2, 3. They're in even positions: 2, 3, 4, 5, 6. And I can also just maintain the way here. Can maintain the first 2 letters, and I can replace this to be E-S-I. So that is another way. I've just replaced this And so if you do that, you go up to 36 times. You can rearrange these letters and then ensure that the vowels are only in the even positions. You go up to 36, you form 36 words. You form 36 words. Because you're also arranging the vowels and the consonants at the same time. Let's look at another question. Now, a group contains 8 male and 6 female. Find the number of ways from the group. Now, the first one is very easy because a group has only 14 members and want to select 5 out of this 14. And then B, select a 5-member committee, and this committee of 5 and 2 female. And then we have the last one, vice chairman, and the secretary from the group. It involves combinations. We have 5 members out of 14. What does the question say? Just scroll up. Ways to select a group. So this question involves combination. We have 14 members in the group and 5 out of that. So 14 factorial out of 5 factorial times 9 factorial. 5 from 14 to 9. And you use your calculator and see what you get. And this other one, you are told to select 5-member committee, 3 should be male and 2 should be female. So 3 male out of 8 male would be combination 8-3, which is 6, and which is 15. And therefore, since we want this 3 male and 2 female, we would multiply this 56 by 15 to find the number of ways, 140 ways, in which you can come up with a group, a committee that has 3 female, 3 male, and 2 female. Now, chairman, vice chairman, and a secretary. This does not involve combination. It does not involve combination. It involves permutation. Because this group has 14 members. Out of these 14 members, we want to elect a chairman. We have 14 ways in which you can elect a chairman. After electing the chairman, okay, we have 14 ways in which you see any of these members qualifies to be chairman. So you have 14 ways of electing a chairman. So that is if you have person 1, person 2, person 3, person 4, all the way up to person 14, this person can be a chairman. That is one way. This person can be a chairman. That's the second way. This person can be a chairman. That is the third way. All the way up to this person can be a chairman, and that is the 14th way. Now, after electing the chairman, you are left with the 13 persons. You are the vice chairman. So any of those 13 persons qualifies to be a vice chairman. So again, you have 13 ways of electing vice chair. After electing a chairman and a vice chair, you elected the 2 people out of 14, so you're left with the, was it 40? Yes, out of 14, you're left with the 12 persons. Any of those 12 qualifies to be a treasurer. So the question is, find the number of ways that you can elect a chairman, a vice chair, and a secretary from this group. So the number of ways are this product. This product gives you the number of ways. So this question, as I said, does not involve combination, but it involves permutation. And of course, it's just the same as permutation. 14 members, you're picking 3 at a time. 14 members, you're picking 3 at a time, and you get the same answer, 2,184. Or we just reasoned the way I reasoned earlier. I said you have 14 ways of electing a chairman. Then you have 13 ways of electing a vice chairman. Then you have 12 ways of electing a treasurer or a secretary. And then the product is what we require as the answer to the question. Now let's look at a similar question. A box contains 9 blue stickers, 7 red stickers. Find the number of ways that a 3 sticker can be picked from the box, if they can be any color, and if they must be the same color. We want 3 stickers from the box. This box has how many stickers? It has 9 plus 7, which is 16. And you want 3 at a time. Of course, it involves combination and not permutation. Just want to pick 3 and put them somewhere. And pick another 3, put them somewhere. Pick another 3, put them somewhere, without following any order. And this will be 16 factorial divided by 3 factorial times 13 factorial, which is 560. There are 560 ways in which you can select 3 stickers from 16 stickers. Now, this question involves colors, and it says they must be the same color. They must be the same. So if they must be the same color, then there's a possibility they could be blue. So you could have, we can select 3 out of the blue, which are 9. Or we can also select 3 out of the 7, which are red. So it could be this number of ways or this number of ways. So that is how we do that part B. And after getting those number of ways, of course you add, because it's the first one or the second. So you add those number of ways. So we say that we could either have blue stickers or red stickers. So that means then we add these 2 results to get 119 ways. Find the number of ways of forming a committee of 6 with a chairman from a group of 13 members. So you have 13 members and you're asked to form a group of 6, a committee of 6 members. And one of these 6 should be a chairman. So first of all, you will begin by electing a chairman from 13 members, and you have 13 ways of electing a chairman. Selecting a chairman from this. After we selected a chairman, you are left with 12 people. These 12 people want to choose 5. So the order does not matter. Just select 5 out of 13. So it will be combination 13, 12, 5. Because there were 13 and you already elected a chairman, so you're left with 12. And this will be 12 factorial out of 5 factorial times 7 factorial. That gives you 792 ways. Now, since you need this chairman and these 5 members, so your result will be 13 times 792. That's what you have. Those are the required number of ways. Those are the required number of ways that if you are given 13 members, you can elect a chairman and then elect 5 other officials. Let's look at this one. 4 stickers are drawn from a box having 13 stickers. No, having 30 stickers. Find the number of ways this can be achieved with the replacement or without replacement. With the replacement, is very easy. Every time you draw and replace, so the first time you insert your hand in the box, you have 13 stickers. You draw 1 and then replace it. So the second time you draw, you have again 30 in the box. Then replace, you go the third time, they are 30. Then replace, you go the fourth time, they are still 30. The question is, find the number of ways 4 stickers can be drawn. So the first time you inserted your hand in the box, they were 30. The second time, they were 30. The third time, they were 30. And the fourth time, they were 30. So there were 30 ways of getting 1 sticker. And then the second time, there were 30 ways of getting 1 sticker. The third time, there were again 30 ways of getting 1 sticker. The fourth time, again, there were 30 ways. So this will be the same as 30 raised to, which is 81000. So those are the number of ways that you can draw 1 sticker from 30 stickers with a replacement. What about without replacement? The first time you go to draw, there are 30 stickers. You draw 1 and place it aside. So the second time you go to draw, there are 29. So you have 29 ways of getting 1. Draw that 1, put it aside. There are left 28. So when you go to draw, you have 28 ways of getting 1 sticker. Then put it aside. When you go the fourth time, there are only 27 stickers. And so you have 27 ways of getting 1 sticker. So this will be the same as, this will be the same as permutation. And you have 34. Permutation of 30 objects taken 4 at a time. So this will be the answer for this. And you just calculate. Let me see what I got when I did my calculation. This is what I was getting. That you can use the first reasoning or you can use the second reasoning for this second question. For this second question, you can use the first reasoning or the second reasoning. The first reasoning is where you're going to draw, and this box has 30 stickers. You pick 1 and place it aside. So you picked, there were 30 ways of selecting 1. Now, when you go back to the container, that container has 29. So to pick 1, you have 29 ways of picking 1. And so that is my reasoning. Now, this is also interesting question that I want you to understand, that find the number of ways that 8 people can be arranged in a row of chairs. So if they are arranged in a row of chairs, that is the question. The first one, it means there is permutation. And you see, you have 8 people. You have 1, 2, 3, 4, 5, 6, 7, 8. These are 8 chairs. So for person 1 can sit here, second person sit there, third person, and so on. Or you can have person 1 sit here, then person 3 follow, then person 2, then 4, 5, 6, and so on. You can rearrange these numbers. And that means that if you have 8 persons, then you'll have 8 factorial ways in which they can sit in a row of chairs. But if it's around a table, what normally happens is there are 8 people. You come and fix 1 person. Is a table, or they want to form a circle. So you fix 1 person here. You are left with 7 people. So these 7 people should now sit starting from this person. And they'll sit in 7 factorial ways. They'll sit in 7 factorial ways. So that means that if you arrange people in a circle, then you can arrange them in n. If there are n people, then you can arrange them in n-1 factorial ways. That is why we had 8 people here, and we will arrange them in 8-1 factorial ways, which is 7 factorial ways. So if they are sitting around a circle, this is how we do it. And if they're sitting in a row, this is how we do it. It will be just 8 factorial. If they're sitting in a row. And this is what I did. And these others, since they're sitting in a circle, will be arranged in a circle in n-1 factorial ways. These are very good questions. Let's look at this other one. It appears simply here. A box contains 4 green stickers, 5 blue stickers, and 6 yellow stickers. In how many ways can 4 stickers be drawn? Yellow stickers are to be included. Of course, we've done a question like this before, but it's not bad to repeat so that we understand the logic here. We need at least 2 yellow, and we want to draw 4 stickers. So it means the first option, 3 yellow out of the 6. And I also want to select 1 non-yellow out of the 9 non-yellow. You can do this combination and do this combination. That's what I have. Now, the other final option is where I have 2 yellow plus 2 non-yellow. So that I have 4 stickers. I have 2 yellow stickers and 2 non-yellow stickers. That gives me 4. So these 2 yellow ones, I'm selecting them from 6. And these 2 non-yellow ones, I'm selecting them from 9. And that's what I have. And when you do that, the question was, in how many ways can 4 stickers be drawn from the box if at least? That means you would then add all these options. Add this option plus this option plus this option. Add all those options. That's what I did here. That's what I did. You can do this and get 735. Now look at this. 30 buses operate between towns A and B. In how many ways can a traveler move from A to B different bus? So this person might want to use the bus X from A to B, and then when coming back from B, you should not use bus X. Use a different. This traveler has 30 choices. So the traveler can move from A to B in 30 ways. So he's using 30 buses. So he can use either 30 choices. But now coming from B back to A, this traveler has only 29. The number of choices will be 30 times 29, which is 870. That's a very good question. Now let's look at the next question here. It says, in how many different ways can 7 men and 7 women sit around a circular table? So it's very different from the earlier one, but you remember the word around a circular table or in a circle, that we are talking of n-1 factor. So we want to sit the men first. Let's just sit the men first, or we can even sit the ladies first, and then the other ones just fill the remaining spaces. So if I'm sitting the men first around a circular table, then it will be 7-1 factorial, which is 720. But now the men have already seated. So the ladies will now come to sit in 7 factorial ways. So I don't subtract 1. The ladies will now sit in 7 factorial ways, which is 1040. And therefore, the total number of ways will be this times this, which is this. And as I said again, there's no problem if you were to sit the ladies first in 7-1 factorial ways, and then come and sit the men in the 7 factorial ways, and then multiply the result. There will be no harm in doing that. But that's how we do this question. Of course, you now understand again how to do a similar question to the one we did earlier, but a slightly different approach. Let us proceed to the next question. Find out the number of possible outcomes. So a coin is tossed 4 times. So you know the coin has the head or the tail. So when you toss it once, you expect to get either the head or the tail. So these are 2 outcomes. So on a single toss, you have 2 outcomes. Now when you toss it next time, again you have the same chances that you may get a head or a tail. There'll be another choice, 2 other outcomes. So every time you toss that tail, you have 2 outcomes. So if you are to toss it 4 times, you have 2 times 2 times 2 times 2, which are 16 outcomes. 16 outcomes. In fact, you could have used a tree diagram and come up with the same results. And in fact, when you use a tree diagram, you can also tell what the outcomes are, because a single toss will give you head or tail, and then the other toss will give you head or tail. This one, head or tail. I don't have enough space. So you tossed it twice. So when you toss the 3rd time, you have head or tail. 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 Now the 4th time, you have head or tail. 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 You know how to draw that. Now, these are possibilities. You have head, head, head. You have a possibility of 4 heads. The other possibility is 3 heads and a tail. 3 heads and a tail. The other possibility, so I've used this root. Then I've used this root. You can also have this root. Head, head, tail, head. Or this root. Head, head, tail, tail. And so on. So you have, those are the possibilities. This is the first possibility, the second possibility, or the 3rd possibility, the 4th possibility, 5th, 6th, 7th, and so on up to the 16th possibility. Now look what this other is. Finally, it's supposed to be from the bag. It's supposed to be from the bag. A with the replacement and B without replacement. You've already done a similar question. If you're doing without replacement, it would be 9 raised to 4, which is 65, 61. That means the first time you went to draw, there were 9. So you had 9 ways. You went back to draw the third, another one, and there were still 9. You went to draw another one, and so on. But without replacement, the first time you went, there were 9. The second time you went to draw, there were 8. The 3rd time, there were 7. And then there were 6. Or you can say P 9 balls, and you're selecting 4 at a time. You can say that. And you get the answer. We did a question similar to that. Just repeating them slowly. Now let's look at number 1 to this could be 3-digit numbers, can be 5, 7, 9. So formed must be divisible by 2. And then 1, 2, 3, 4, 5, 6. We want to form numbers, 3-digit numbers which are divisible by 2. 3-digit numbers which are divisible by 2. Now, what do you need to know that for a number to be divisible by 2, then the last digit, the ones digit should be even. Ones digit should be even. That means the ones digit should be 4. The only possibility is it must be 4. So how many possibilities do we have? How many choices do we have for the ones digit? 4 So for the ones digit, we have only one possibility, that it must be 4. Let me see, we want to create 4 digits. No, 3-digit number. So if we've already placed 4 here, we have only one possibility for the ones digit. So why placing 4? We say that for this number to be divisible by 2, the last digit must be even. So the only possibility we have for an even digit is that the only even number here is 4. So we only have one chance, one choice. We only have one choice for the ones digit. Now, from there, let's now check to see, because we want, so how many choices do we have now for the first digit? How many choices do we have? Or let's just even come for the second, this 10th digit. We've already eliminated one digit, and we are left with 1, 2, 3, 4, 5. We are left with 5 digits. We have 5 possibilities for this, tens position. Now, so that means we've now eliminated out of 1, 2, 3, 4, 5, 6 digits. We've eliminated 2. We are left with 4. So we have 4 choices for the 100th digit. So the question is, how many 3-digit numbers? So we can form 4 times 5 times 1, 23-digit numbers. We can form 23-digit numbers. And this is my reasoning. So at your own time, you can go through it, but I've already explained it. I've already said a number is divisible by 2 if the last digit is given. So that means we begin by fixing the last digit. So the only even number is 4, and so we place it in the ones digit. So there is only one way of doing this. Here are the number of choices, not the number, not 4, but the number of choices is just 1. You have only one choice for an even number. Then after, if you have 6 or 7 digits, we get 6 digits. We've already fixed the last one, the last in the ones position, So we would be in the 10th position. So since there are 5 ways of choosing one of them. Now, so we've chosen 2 numbers. We are left without or is qualified to be in this. There are 4 ways of selecting 2 is 20. That we can even. So this question, we reason the rings of different types be worn in 5 fingers. So you have the 5 fingers and you want to wear, you have 8 rings. So I've said that the first ring, so out of this 8, your first ring can be worn in any of the 5 fingers. If you get the first ring, you have 5 ways of it wearing a ring. What about the second ring? The second ring will also have 5 ways because it can be worn in any of the 5 fingers. Then what about the third ring? You can also pick the third ring of the remaining 6. Because you had 8, you know the fingers. It had 8 ways of doing that. Then the remaining 7. Of this one, you choose one. This one also has 5 ways. It can wear those fingers in, and the one on those. So that means each of those 8 rings has 5. So that means the number of ways that 8 rings can be worn in 5 fingers is 5 times 5 times. So this is the way. This is a number of ways for the first ring, the number of ways for the second ring, the number of ways for the third ring, number of ways for the fourth, number of ways for the fifth, number of ways for the sixth, number of ways for the 7th ring, and number of ways for the 8th ring. And so the product is that. That's how we do that question. Now, again, a similar question here. Suppose each working day of a boarding school has 8 periods. In how many ways can each subject is allowed at least 1 period? So you have 8 periods, and you have 6 subjects. And of course, you notice that the periods are more than the subject by 2. So you have two more periods. Two more periods. Now, so let's just begin by arranging these six periods, 6 subjects in the 8 periods. So the number of ways that 6 subjects can be arranged in 8 periods would be this. This will be the number of ways. And after this, we are left with the two periods. So any of the 6 subjects will be arranged in the remaining 2 periods. And these are the number of ways. These are the number of ways that we can arrange 6 subjects in the remaining 2 periods. We have this, and we have this. Now, so what you notice is that there's some 2 subjects here which have been arranged here. They were already arranged here. So that means you have 4 subjects which have repeated themselves. 4 subjects repeated. So that means what the question therefore wants is this product times this product divided by 4 factorial. This product times this product over 4 factorial. And we are dividing by 4 factorial just to avoid counting some of these subjects several times. Because some of them have been repeated, and you've already seen that the 2 here have already been taken care of here. That means there'll be a repetition. 4 subjects will be repeated. So this is my reasoning, and that's what I've written. That's what I've written. So at your own time, go through it and write your notes. Now let's look greater than 3,000 can be formed from these digits if each digit is to be used only once. So what will help me here is the word odd. How many odd numbers? So a number is odd if the last digit is odd. So the last digit should be either 3, 5, or 7. The last digit should be that. So this will help me. The word odd will help me. And the other thing that will help me is the word greater than this. So that means the first digit should be either 3 or greater than 3. So let me now start fixing my numbers. So I want to, there are 2 possibilities for this. So we begin by fixing the first digit. So the first digit can be either 3 or 5 or 7. So once you fix, so how many chances do you have for the first digit? So you have 3 chances. 3 chances for the first digit. It could be 3 or 5 or 7. So we need a number greater than 3,000. 3,000 has how many digits? Has 1, 2, 3, 4 digits. It has 4 digits. So we have 3 chances for the first digit. Once I fix the first digit, if it's 3, then it means I have 2 chances for the last digit. 2 chances for the last digit, because the last digit is supposed to be odd. And since I've already fixed 3, for instance, I'm only left with the 5 and 7, which are odd. Or if I was to fix 5 first, then I'll be left with 3 and 2. So I would have 2 chances for the last digit. Now let me now come and fix the second digit. I've already fixed the first digit, and I've also fixed 1, 2, 3, 4. I've also fixed the 4th digit. So I've fixed 2 digits out of 4. So I'm left with the 2. That means I have 3 chances for the second digit. And then that means I've fixed 1, 2, 3 digits out of 4. So I'm left with one chance. I'm left with one chance for the third digit. So the number of chances therefore are 3 times 2 times 1 times 2, and these are 12. These are 12. And so that's what I've explained here. That's what I've explained. I've said that in this number, if this number is greater than 3, then the first digit can, there are 3 ways. So I've written 3. This 3 is for the 3. The first digit has been fixed. So let's fix those 2. That means those 2 have 2 chances. So it could be 5 or 3. Or maybe if the first one was 7, then it will be 5 or 3. Now, once I've fixed in the first position and fifth position, I'm left with the 2 numbers. And any of those qualifies to be in the second position. So as I have 2 in second position. Once I've fixed a number in the first position, the last position, and another one in the second position, there were 4 numbers. I've fixed 3, I'm left with 1. So I have this. I would have 12 odd numbers. Let me just show you by an example. In fact, these were 2, 3, 5, and 7. 2, 3, 5, and 7. Just show you. The numbers that we have are 2, 3, 5, and 7. 1 to form odd number greater than 3. So I said that we have chances where for the first digit we have chances either it could be 3 or 5 or 7. Let me take it to be 3. Now, if I was to suppose that the first digit is 3, then it means that the last digit could be 5 or the last digit could be 7. Because the last digit is supposed to be odd, so it could be 5 or 7. So if it's 5, then I'm left with either that this would be 2 and this would be 7. Or if it's 5, this could also be 7 and this 2. Now, if it's 7, if 7 is the last digit and 3 the first one, then this could be 2 and this one could be 5. Or I can also have 3, 5, 2, 7. So if 3 was to start and 5 be the last digit, I have this possibility and this possibility. And if 3 was to start and 7 is the last digit, I have this possibility and this possibility. Now, I also have another possibility that 5 can begin. If 5 begins, then the chances that I have for the last digit is either 3 or 7. So let me assume it's 3. If it's 3, then this would be 2 and 7, or I could have 7, 2, and 3. Now, if 5 was to start, the other possibility I have for the last digit is 7. If it's 7, then this could be 2, 3. Or this could be 5, 3, 2, 7. So this is the other possibility. If 5 was to start, I can form this number, I can form this number, I can form this one. And all these numbers are greater than 3,000. Now, the other possibility I have for the first number is 7. That 7 can be first. And if 7 is first, then I have that this should be 5. Or if 7 is first, I have that this should be 3. Because it must be odd number. If this is 5, then I have 2 chances for this number. If this is 5, I have 2 chances for the second number. I began with 7, so if it could be 2 or 3. It could be 2 or 3. So if it's 2, then this will be 3. If it's 3, then this will be 2. And this will be 2, 5. and this will be 5, 2. So these are the numbers, and you discover these will be 12 numbers. And you see the reasoning. The reasoning was that how many chances do you have for the first number? And for the first number to be greater than, for this number to be, for the number formed to be greater than 3,000, then we have 3 chances that it could be 3 or 5 or 7. For the first number has 3 chances. And then what about, once you fix the first number, in fact, the first number would be odd because only odd numbers here are greater than 3 or equal to 3. So, but you see the last digit is supposed to be odd, so we are left with 2. Now, once you fixed the first and the second number, those are 2 numbers, you're left with the 2 other numbers, and any of them qualifies to be the second number. Once you fix these 3 numbers, 1, 2, 3, you're left with a number. This gives you 12. Let's look at another question that is similar but slightly different. And it's this one. The question is, can be formed from the digits, basically ones in each number. So how many odd numbers can you form? And those odd numbers should be greater than 40,000. Now, for these numbers to be odd, 1, we understand that the last digit must be odd. So the last digit must be 3, 5, or 3. That is very important. So that's how we shall be reasoning. But before that, let's count our digits. 40,000 has 1, 2, 3, 4, 5 digits. 40,000 has 5 digits. What about the digits given to us? 1, 2, 3, 4, 5, 6. These are 6 digits. These 6 digits can form a 5-digit number greater than 40,000, or can also form a 6-digit number greater than 40,000. So you can form either a 5-digit number which is greater than 40,000, or you can form a 6-digit number greater than 40,000. Let's begin by forming a 5-digit number greater than 40,000. 5-digit number greater than 40,000. So the first digit could be either this, or this, or this, or this. The first digit could be any of this. If any of this is the first digit, then the number formed will be greater than 40,000. So let's begin by when the first number, I started by saying, okay, we will have 2 possibilities. For us to form a 5-digit number greater than 40,000, we have 2 possibilities. The first possibility is when the first digit is odd, because we have this. And the first digit is 5 or 7 or 8. No, 7 or 5. And the second possibility we shall look at it is when the first digit is given 4 or 5. No, 4 or 8. So which one did I begin with? I began with the odd possibility. I said that the first possibility is when the first digit is odd. So how many chances do we have for the first digit to be odd? For the first digit to be odd, the chances that we have is that it should be either 5 or 7. So those are 2 chances. Then from there, we go to the last digit. The last digit is supposed to be odd. So the last digit is supposed to be odd. So it's either 3 or 5 or 7. But I've already fixed an odd number here. I've already fixed one odd number. So I'm left with only 2 odd numbers. I'm only left with the two odd numbers. That means the last digit has two chances. Once I've fixed these two, I've fixed a digit here and a digit here, I'm left with the 4 digits out of 6. Because I had 6 digits, I'm left with the 4 digits. Any of these 4 qualifies to be in the second position. And so that is why I said that I have 4 chances for the second letter, for the second number. So that means I would have now fixed one here, one here, and one here. Those are three numbers fixed. Out of 6, I'm left with 3 numbers, and any of them qualifies to be in this position. So I have 3 chances for this position. So 1, 2, 3, 4. 4 numbers have been fixed. Out of 6, I'm left with the 2 numbers, and any of them qualifies. So I have 2 chances for this position. So if I was to form a 5-digit number and begin with an odd number, if the odd number was to begin, I would form this number of numbers. I would form 96. So I will have 96 possibilities. 96 possibilities. So that is the first option when forming a 5-digit number and an odd number being first. Odd number being first. Let's now look for the other option where the even number is the one first and still forming a 5-digit number. So I've said here that it's something that okay, so the second possibility is when the first digit is even. So we want to form a 5-digit number, but the first digit should be even. So how many even numbers did we have? How many even numbers did we have? We had 2, 4, and 8. But a 2 is a 5-digit number. So if 2 is the first number, the number formed will not be greater than 40,000. Either 4 and 8. So those are 2 chances. That there are 2 chances for this has 2 chances. It's either 4 or 8 with an odd number. So how many chances do we have? We have 3 is odd, 5 is odd, 7 is odd. We have 3 chances for the 5th digit. First data we have those chances. Now after 5, out of the 6, that means there are 4 chances for the second digit. After fixing the first, the 5th, and the second, those are 3 digits position and 2 chances for this other position. And that's what I have here. 3 chances for the 5th position, 4 chances for the second position, 3 chances for the 3rd position. That means I have 144 possibilities. Now I come back and look at the other possibility. It was when I make a 6-digit, that is, I say, let us now consider 6-digit. And to consider 6-digit number, we reason the same way. We begin by forming where the first is given. So we have 2 possibilities. The first possibility, how many odd numbers are there? 1, 2, 3. You have 3 chances for the, and that's why I wrote here, 3 chances for the first digit. So we had 3 odd numbers, but we've already fixed 1. That means we are left with the 2 for the 6th digit. After fixing a number in the first position and a number in the 6th position, we are left with the 4 number. So that means we shall have 4 chances for this position, second position. We shall have 4 chances. Then we shall have 3 chances. We shall have 2 chances. Then we shall have 1 chance. That's what I did. That's what I did. That's what I did here. These are the chances. I now look at the last chance is even. Because the n, so even have 1, 2, 3. 1, 2, 3. So you have 3 possibilities for the first digit. You have 3 possibilities for the first digit. And then from there, we're going to fix the odd numbers. So you have 3 possibilities again for the last digit. So you fix the 1 number here, another number here. Those are 2 numbers out of 6. That means we are left with 4 numbers. That means you have 4 possibilities, 3 possibilities, 2 possibilities, then 1 possibility. So the number of possibilities, therefore, is 216. So the question was, how many odd numbers greater than 40,000? We add all those possibilities. The first one was 9616. That gives us 600 possibilities. So those are the numbers you can greater than 40,000. That's how we do it. Thank you for watching. And if you've not subscribed, remember to subscribe so that whenever you upload, see it. Thank you.